Welcome to my Advanced Database Management System course. In this section, we discuss about distributed databases and CAP theorem, partition tolerance, implications of the CAP theorem. Let's enjoy. Distributed databases are database systems that store data across multiple nodes or servers in a distributed manner. These databases are designed to handle large volumes of data and provide high availability and scalability. However, distributed databases face inherent challenges related to consistency, availability, and partition tolerance, as described by the CAP theorem. CAP theorem. The CAP theorem, also known as Brewer's theorem, states that in a distributed system, it is impossible to simultaneously achieve all three of the following guarantees. Consistency. Consistency refers to the guarantee that all nodes in the distributed system will have the same data at the same time. In other words, all read operations will return the most recent write value. Availability. Availability refers to the guarantee that every request made to a non-failing node in the system receives a response, regardless of the current state of the system. Partition tolerance. Partition tolerance refers to the system's ability to continue operating despite network partitions or communication failures between nodes. Network partitions can occur due to factors such as network outages, hardware failures, or software issues. According to the CAP theorem, in the event of a network partition, P, a distributed system must choose between ensuring either consistency, C, or availability, A. It is not possible to guarantee both. Implications of the CAP theorem. CA systems. Some distributed systems prioritize consistency and availability over partition tolerance. These systems sacrifice availability during network partitions to ensure strong consistency. Examples include traditional relational databases like MySQL configured in a single master replication setup. CP systems, other distributed systems, prioritize consistency and partition tolerance over availability. These systems maintain consistency even during network partitions, but may become temporarily unavailable. Examples include systems using consensus algorithms like Paxos or RAF. AP systems. Finally, some distributed systems prioritize availability and partition tolerance over strong consistency. These systems remain available during network partitions, but may provide eventual consistency, where different nodes may temporarily diverge in their views of the data. Examples include many NoSQL databases like Cassandra and DynamoDB. Considerations. Trade-offs. Designing distributed systems involves making trade-offs between consistency, availability, and partition tolerance based on the specific requirements of the application and the desired system properties. Tuning parameters. Distributed databases often provide configuration options that allow developers to adjust consistency, availability, and partition tolerance based on application needs. Quorum systems. Some distributed systems use quorum-based techniques to achieve a balance between consistency and availability during network partitions. By carefully configuring quorum settings, these systems can provide different levels of consistency and availability. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson.